So we are going to be looking at some type of baseball today in today's reactions. It's going to be used as an analogy. We're going to be getting into a concept called electrochemistry, and it involves the throwing and the catching of an electron. And this is involved what's called a redox reaction. So let's go ahead and take a look and see what a redox reaction is. So look at the word redox. Redox actually can be divided into two parts. We have the RED for the reduction part, and we have the OX for the oxidation part. So I've written a lot of information here, and because it's a lot to take in, I want to make sure that you have it recorded and not just have it verbally. So in a redox reaction, the oxidation reaction takes place first. So we have two parts of the redox reaction. We have the RED for the reduction, and we have the OX for the oxidation. So the oxidation takes place first. However, it's not called an ox-read reaction. It's called a redox reaction. That's just the name it's developed over time. So the second part is going to be the reduction. So the oxidation takes place first, and the reduction takes place second. So it's sort of like the pitcher and the catcher, okay? The pitcher is throwing the ball first, and the catcher is going to be catching it second, okay? So again, down below here we have the reduction, we have the oxidation reaction, and again, the oxidation takes place first, and the reduction reaction takes place second. So first of all, what's happening in each of these chemical reactions? In a reduction reaction, what's happening is you're gaining the electron. In an oxidation reaction, you're going to be losing the electron. So here's the analogy. Imagine you have a pitcher and you've got a catcher, okay? Question is, who has the ball? Okay, right now the pitcher has the ball. What does he do with the ball? Okay, the answer, he throws it. Okay, what does the catcher do with the ball? He's going to catch it. So there's this event, this throwing of the ball involves these two players, and it involves the actual ball itself. Okay, so let's take a look at this. So the pitcher throwing the ball is the oxidation reaction. So this is sort of like the pitcher. Okay, he's throwing the ball first. The catcher catching the ball is the reduction reaction, since this happens second. So this is like the catcher. And the ball is the electron. So here we have the pitcher. Okay, this is the oxidation reaction. He's going to be losing the ball. Okay, the ball is then going to be thrown. Again, the ball is this electron. So he's just lost the electron, and it's being thrown to the catcher over here. So the catcher now gets the electron, and now we've had a reduction reaction take place. So a redox reactions, these occur simultaneously, meaning at the same time, meaning you can't have an oxidation reaction without a reduction reaction. And you can't have a reduction reaction without an oxidation reaction. Refer to the analogy. When a pitcher throws a ball, you have to have someone to catch it. You have to have the catcher. Also, a catcher cannot catch the ball unless it's been thrown by the pitcher. Likewise, a substance can't just lose its electrons out into nothingness unless it has another substance that's willing to gain it. The electron simply cannot be thrown into the air. It needs somewhere to go. So let's take a look at this first of the reactions. We can take zinc and this substance called ammonium nitrate. Ammonium nitrate is actually a fertilizer, and it's very, very explosive. This is a demonstration that I usually do inside the hood, but it's quite messy as well. But we're going to assume that this reaction's been done, and it produces fireworks-like effects. So looking at this reaction, we're going to be taking the zinc with this ammonium nitrate. It's going to create nitrogen. It's going to create zinc oxide. So what's going to happen in this case is the zinc is going to be the pitcher in this reaction, and this ammonium nitrate is going to be the catcher. And so therefore the pitcher is going to be throwing or losing the electron. And so this oxidation reaction, again in a redox reaction, the oxidation reaction takes place first. It's the pitcher. So the pitcher is going to be throwing the ball. In this case, the zinc is going to be throwing the electron, and it is going to be oxidized. It's the oxidation reaction. So I've written ox right here, and I've written for oxidation, and RED for reduction. Well, let's take a look at what's happening in this reaction. The zinc is becoming, in this reaction, it's becoming zinc oxide. So let's take a look at what's happening in this reaction. We have zinc that is solid. So we're going to write zinc that's solid right here. And the charge of zinc right now in its elemental state is going to be neutral. So I'm going to put a little 0 here, indicating that it's not a negative charge, it's not a positive charge, it's neutral. But look at what it becomes. It becomes zinc oxide. So in this reaction, it becomes zinc oxide. Well, if you look at the periodic table, oxygen is group 6. It's 2 away over from the noble gases. And you remember the charge of group 6 is a 2 negative. What's going to match this 2 negative is going to be a 2 positive. So we're going to ignore the oxygen, and we're primarily concerned with the zinc. What happened to the zinc? It went from being neutral to now having a charge of 2 plus. Well, how does something become 2 positives with reference to electrons? If you go from 0 to 2 positives, in order to become positive, you have to lose those negatives. So it loses, in the process, 2 electrons. That's why zinc is the pitcher. It's throwing the 2 electrons. And what it's doing is it's throwing it to this compound right here. So here this compound is sitting right next to the zinc. Let's take a look at this. This is going to be receiving the 2 electrons. So we're going to draw this little dotted line over here. And we're going to start now with these 2 electrons. These electrons are being thrown by the pitcher to this catcher. And we're going to be starting off with this substance called ammonium nitrate. NH4, NO3. The charge of a nitrate polyatomic ion is a negative, and the charge of a polyatomic ammonium is going to be a positive. So this is starting off charged, and it is going to accept these. And actually, we're going to have 2 of these ammonium nitrate molecules to accept the 2 electrons. Each ammonium is a positive charge, which means that it can accept 1 electron. So 2 of these molecules are going to accept the 2 electrons. This is the catcher. And look what it becomes. These nitrogens over here become nitrogen gas, and this is going to be the elemental nitrogen, meaning it's not going to have a charge. So it's going to end up becoming nitrogen, and it's going to be neutral. So it goes from a positive charge to becoming neutral. How do you go from a positive charge to neutral? You're going to have to gain a negative in order to become neutral for this. So in this reaction, the first reaction, again, this is the oxidation reaction. This is the oxidation reaction. And this is, again, the example. This is going to be the pitcher. The pitcher is going to throw the electron, and in throwing the electron, it is going to lose that electron. The zinc loses the electron, and it becomes positively charged. And again, the second reaction, this is the reduction reaction, and this is going to be the catcher. And the catcher is going to gain the electrons.